Thunderstorm is a phenomenon. Take a look at this picture. You'll be able to appreciate how does it going to look like. That is lightning, thunder, and the type of clouds that you go on to see in this place, and the flickers of thousands of such type of lightnings that are going to be a part of it. Now that is the spectacle of a thunderstorm. When we're going to be talking about this type of a thunderstorm, we are essentially talking about a localized phenomena, or it can go on to be a larger phenomena. Thunderstorms are essentially local storms, violent storms that develop from cumulonimbus cloud on a hot and humid afternoon, and always accompanied by some degree of a lightning and thunder. All thunderstorms form due to rising of warm air from the ground. The air may rise due to heater, ground heating, which promotes vertical motions in the air, supply of a significant amount of moisture from near the ground, and the sucking effect of air by winds high above, which causes the air to rise. This can happen because of divergence of jet stream like the one that happened during Kedarnath. In the presence of these conditions, a triggering effect is required to initiate a thunderstorm. And this triggering effect can go on to be because of heating from below, producing warm air and convection, upliftment over mountains, or an upliftment along two different air masses having contrasting temperature and humidity. The development of a thunderstorm is a phenomenon to be seen. Thunderstorms are accompanied by lightning, they are accompanied by high velocity winds, they are accompanied by thunder. Of course, lightning hits the air within a narrow limit to a very high temperature, and that causes the air to rupture in that place. What you're going to see is a development of a thunderstorm that is going to be in a form of a photograph. There is a time-lapse photograph, and how is it that they go on to evolve over time. And once they go on to evolve over time, they can go on to lead to a massive outpouring of rainfall in one single place. They can go on to lead to a series of intense lightnings here and there, and the way the clouds go on to be developing in this place. And you can also go on to see that it can go on to be of a different type of a dimension altogether. That is, thunderstorms do not go on to take so much amount of a time to develop. They go on to develop gradually, and then they're going to get themselves speeded up in the process of their growth. And that is what goes on to make a thunderstorm very, very distinctive. India had experienced one season of thunderstorms where there were thunderstorms, and there were a series of thunderstorms that took place spread over about 1 month of a time in 2018. What exactly are these thunderstorms? How is it that they go on to form to lead to such a type of a phenomena that you go on to see? This is something seen to be believed of sorts. Thunderstorms form as warm air rises. That is called as updraft. This rising air causes water to evaporate and carry the moisture upwards to form clouds by condensation. The clouds then builds and grows up to almost about 16 kilometers. These clouds become dark and heavy. Cold, heavy air from the upper part brings this moisture downward, called as a downdraft, and this goes on to cause rains below. That goes on to become a very simple mechanism for the formation of these thunderstorms. Thunderstorms are full of energy and are energy reservoir. They get their energy from the condensation in the clouds, and typically thunderstorm goes on to consist of several such type of parts. That is the base of the thunderstorm, that is a cumulonimbus cloud, and the top of it is going to be the anvil. The top can go on to be as high as it can go on to be 16 kilometers. The temperature below may be 20, 26, 25 degrees centigrade, while temperature at the top of it can go on to be as low as minus 70, minus 80 degrees centigrade as well. This is where if a pilot goes on to somehow come, they will go on to find it very, very difficult to glide all along. When you are in aviation, the first thing that you're going to be told is that is whenever you go on to see such type of a cloud called as a cumulonimbus cloud, simply run away from that. Just run away from that. And these thunderstorms are going to be identified by an updraft, that is the air rising upward, downdraft, that the air moving downwards, and this condition goes on to cause it to move in such a manner. So thunderstorms are essentially an energy phenomena. They are full of such type of energy which they go on to be getting it from the condensation in the clouds. As clouds in the thunderstorm develop, excess negative and positive charges form, and at a certain point this builds up opposite charges which lead to transfer of electrons in the form of lightning. This transfer occurs so quickly that it breaks the sound barrier, and the air that is heated to something like some 75,000 degrees centigrade, which ultimately we go on to be hearing it as a thunder. In fair weather, the ground is negatively charged to balance the positively charged ionosphere. Ionosphere is made of protons, and that is positively charged, and the ground is going to be negatively charged to balance that part. During a thunderstorm, however, the negative charges that form in the cloud could repel the negative charges in the ground. The negative charges are pushed deep into the ground, which becomes positively charged, as a result again producing a lightning flash. There are 4 types of thunderstorms. One is single cell thunderstorm, which are isolated, small, brief, weak storms that grow and dry within an hour or so. They are typically driven by heating on a summer afternoon. Single cell storms may produce brief heavy rainfall and lightning. You will observe that such type of thunderstorms go on to occur in one part of the city and another in another part of the city. The second is multicellular thunderstorm. Multicellular thunderstorm is a cluster of thunderstorm that is composed of multiple cells, and each one of them being at a different stage in the life cycle of a thunderstorm. The third is a squall line. Squall line is essentially a group of collection of storms which are arranged in the form of a line that can be hundreds of kilometers long, but are typically only about 10 to 20 kilometers wide. They are often accompanied by squalls of very high wind and heavy rain. So you can go on to find that there is a line of thunderstorms that sometimes goes on to accompany you. This is something that has been observed in United States, particularly in the prairie region of United States, which also happen to be regions of breeding tornado as well. The fourth is supercell thunderstorms. A supercell is a long-lived. The long-lived, that means generally more than an hour, and a highly organized storm that is tilted and rotating. That is, it doesn't go on to become stationary like most of the thunderstorms go on to be. This rotating updraft, as large as 16 kilometers in diameter and up to 16 kilometers top, that means reaching to the top of the troposphere, can be present as much as 20 to 60 minutes before a tornado forms. Scientists call this rotation as a mesocyclone when it is detected by a Doppler radar. Most large and violent tornadoes come from supercells. The North Indian plains during the summer season and just before the summers, they witness a series of thunderstorms and dust storms with differential severity. In one of these years, that is 2018, there were a series of thunderstorms observed in India. And there were many reasons behind this phenomena. As you can go on to take a look at it, there is one of these factors goes on to be the establishment of a trough. This was the trough, and all along this trough there is a low pressure system, there is a low pressure condition. There was unusually very high temperature in Rajasthan to the tune of almost 40 degrees centigrade in this place here. Then there was a trough that has developed during this time. This was called as this preceded the development of the monsoon and low pressure trough. Then western disturbances were a part of it. Western disturbances, that means sometimes they are weak and feeble, and sometimes they do go to intrude into India. So these western disturbances happen to be sometimes intruding into India, and that goes on to increase the severity of it. there was a cyclonic circulation over Haryana during that period of time, and at that low level of cyclonic circulation, that is responsible for giving accentuation to the thunderstorm. You will also going to observe that there were easterly winds. That means some of these winds coming from the sea, from the Bay of Bengal region, and they were into India. That means there was a higher possibility of rainfall being generated in this condition. So, what happened all in this condition, under such a condition, was that a low pressure, that is because of a very high temperature, was accentuated by the sucking of the air from above. That was one. Second was, it was also going to be accompanied by good amount of moisture availability in this place, and a cyclonic circulation that was ultimately responsible for giving it an impetus of sorts. Now that means that the severity of the thunderstorms at that period of a time was very, very high. Normally, or not all the years go on to be associated with such a high degree of severity. But then 2018 was exceptional, and it doesn't go on to mean that it can't go on to be in any other condition or any other year as well. Thunderstorms are not too difficult to predict, but then there are some obvious problems associated with the forecasting. One of them is we have an outdated forecasting model. India uses an outdated, obsolete nowcast model. Now that requires to switch to a contemporary unified model that is hamstrung by some lack of data. We don't going to be having so much amount of data. Second is inadequate Doppler radars. IMD has installed only 25 Doppler radars so far across the country. Now these cover less than 15% of the land area, and moreover they are always going to be affected by a poor maintenance and upkeep of the instruments. In 2018, there were not too many Doppler radars which were functioning as well. That means they were affected by that. Thunderstorms do go on to bring about a local damage to the area concerned, and particularly in the village areas, particularly in the rural areas, which do not go on to be having that much amount of infrastructure. Now that also doesn't go on to mean that the people in those regions don't go on to be having a technology. They used to be having ingenious technology, local wisdom availability, not that they have to replace their hutments with something that is going to be made of concrete. But then with a good amount of forecasting, and in this internet age when people can go on to be informed about the impending dangers of it, the damages to the people can always be minimized. This requires that thunderstorms require to be predicted. Now, the prediction of the thunderstorm is going to be stimulated by the fact that we have outdated forecasting models. India uses the obsolete newcast model, and when we go on to be talking about required new switch to some of those outdated models, then we require to switch to unified model that is hamstrung by the lack of data. At the same time, we also go on to have inadequate Doppler radars. Although IMD has installed 5 Doppler radars so far across the country, they cover only 15% of the land area, and moreover they always go on to be facing an issue of upkeep and its maintenance at the same time. Unless and until these are going to be picked up and they are going to be improved, we'll always keep on relishing at the simple picture and spectacle of the thunderstorm. That is laced with thunder, lightning, high velocity winds, and what not associated with it.